So the topic of my research is the optimization of selection cuts in a search for supersymmetric particle at the LHC. So supersymmetry is a natural extension to the standard model, which helps to answer the different questions left unanswered by the standard model of particle physics. So the standard model of particle physics right here, as you can see, consists of a class of particles called as quarks, and in the red are the leptons, which make up everything that we see in the universe. And right here in the green are what you call it the force carriers, which causes the three different forces with which the leptons and the quark interact with each other, right? And the theory of supersymmetry predicts there should be a corresponding cousin particles to each particles in the standard model. And supersymmetry provides us with the elegant explanation for the Higgs physics and a suitable dark matter candidate that the standard model of particle physics cannot provide us with, right? So right now we are involved in the HL-LHC study, which is an upgraded version of LHC, and that aims to identify discoveries beyond 2029 using the data from round 3 and round 4 at the Large Hadron Collider. And in this study, I will discuss the concept of discovery significance and use this to optimize a set of cuts for different variables. So our objective here at UTA is we are trying to look for the S top S quark, which is the supersymmetric pattern to the top quark, right? And we are looking for the S top pair production, decaying via double boson, bottom quark, and a neutralino in final states containing two leptons. So the methods that we use is the concept of significance, right? So significance is, in simple words, is the ability to distinguish the signal over the background. Here we have the formula to calculate the significance. And how do you optimize the cut, right? So in order to optimize the cut, we have to make the significance plot of n-1 variable. So that means we have a signal region defined by placing a constraint on various leading variables like mean significance, RPT, gamma inverse, and MDR. I have taken this for this study, and we put a cut on that variable, particular variable, and find out the best place to put a cut on that variable. For example, in this measure significance SRT, right here, we have a measure significance SRT, no measure significance. So the signal region top has all the variables except for the no measure significance, right? So just going through briefly here is these are the 4 different supersymmetric signals I have taken for this study. And in this color right here, we have the background. So this is the known predicted by the standard model. And now we want to find the place where the supersymmetric signals might be. So we want to look for the regions where we have more signals than the background, right? So for example, right here from right here on the left, we have more background than the signals. So this is not interesting, right? So we use the significance. So as you can see here, starting somewhere between 14.5, 15, we have more signals compared to the background, right? So for example, on this, so these are 600, 435, which are the mass of S top and mass of neutralino, or simply signal points. We have some interesting events happening after 16, right? Before that, we have all the backgrounds, which is not interesting at all. So optimizing the cut now means we have to only look after the point somewhere around 15 point something that I have. Everything is here in the table right here. But what I mean is we are not interested in the region left to that, right? So similarly, I have this for the 4 different variable, and on the table, I have mentioned about the right place to put the cuts in this 2 table, and this new cut will not now ensure that we have to only examine data beyond these limits, and anything below that would only represent background, which is not interesting at all. So the new cuts will now be used to define the signal region where we'll be looking for the possible supersymmetric signal during the HL-LHC projects. That's it from me. Thank you.